that, and let's start. So we have talked about uh, um, containers and STL containers and vectors. We went through it, strings and vectors, strings and containers, like vectors, list, map, and all the good stuff. Um, and we understood what iterators are and how iterators help you go through, traverse through the vectors and understanding what they are. Do we have any question on this on the last session before I start?
Sorry, so you're not recording on Blackboard.
I'm not. Okay, let me.
Recording on Blackboard.
Is it recording now? I think it
Yeah,
does. Yeah.
thank you.
Okay. Thank you. All right. So we talked about iterators and went through. Let me just bring the last sessions. Give you an example. Like where is it? For example, on vectors. We talked about vectors, and as you see, every single thing that we had, we would call this an iterators. These iterators essentially help us go through the um, uh, containers and go back and forth in them. Um, but iterators by themselves are uh, objects that point at elements the of the of containers that we have, and it has lots of help and purpose to work with it. But iterators by themselves, because they are um, kind of objects that act like pointers to elements, there's we have seen that plus plus and minus minus and things like that are overloaded for them. Let me bring I want to bring some of the things that work with iterators. Yeah, so we said we when we have an iterator, the iterator actually goes through. So if I can say plus plus, minus minus, and I talked about reverse iterators that can go backwards if you want to, things like that. But iterators by themselves, to work with them and make them go around, like traverse through the uh, to traverse through the uh, container, um, they have specific type of utility functions. So um, I want to give you an introduction to iterator utility functions for you to see what they are. So the purpose of these utility functions are to simplify operations on iterators and make them more flexible and powerful for container manipulation. Usually we use these utilities uh, to calculate distance between iterators. Like for example, I have an iterator that is pointing someplace halfway through the vector, and I want to see which index I am at right now. Or I have two iterators. I want to know what is the distance between two iterators. I want to be able to move iterators backwards and forward, not with plus plus, but go 5 steps forwards and 3 steps backwards. I want to be able to access specific elements efficiently or modify containers using iterators. These functions are, I'm going to give you examples of them one by one. So first one is distance. Now distance works like this, and these are all uh, uh, defined in the iterator uh, header file. So for example, I have this vector. I'm going to set the start to the beginning and end to the end, and I'm going to say int distance um, equals to std distance and start and end. And if I run this program, you will see that it actually shows the distance between the two are 5, so I know I have 5 things in a vector. Of course, I could go for the size of the vector, but if it was one of them were pointing here and the other one pointing there, you wanted to see how many elements are between the two. Distance was the one that is the one that helps you do that. So The first one is distance, so a iterator distance. The next one is called advance. Now, what advance does, it actually advances through the container. So I can say get the iterator. So iterator points to the beginning, and I'm going to say advance twice, which essentially means it's going to go two elements further in the vector. So if I run this, you will see, oh, sorry. If I run this, you will see that it says advanced iterator two times. And when I run this, you'll see it starts from 10, it's going to jump to 30. So it was on 10, it went 1, 2, so it's going to, so if you want an iterator to go three times forward, you use advance for it. The other one is going to the previous and next. So um, what it does, the previous and next utility functions for iterators, they return a new iterator advanced forward or backward without modifying the original one. So if you have an iterator that is pointing to a specific element of the container and you want this thing to go to next third without changing the first one, then that's what's gonna that's next is what you need. This is an example for it. So this one was advanced B. So as you see over here, I could actually do something like this. Auto beginning is so now beginning is pointing to the beginning. Now I can say from beginning go three further and put it in iterator. So this it over here will point to three further, and big remains the same. So value at next year, yeah. So and I'm gonna say uh, beginning, and in here I'm gonna put beginning, and the other one is gonna be mm, oh using namespace std. And if I run this, you'll see that the beginning remains the same and the other one is 40. So if you want an iterator going advanced from specific iterator that you have without changing it, you can use next. So that's gonna be, are we okay down to this point? I just don't know because it's quiet. I don't understand it. I don't know if you're getting it. I cannot look at your faces. Just want to make sure. If you see I'm going too fast or there's something over here that you don't understand, please stop me, okay? And the exact same thing we have for the previous one. So this is previous one. So I'm going to say from end go two backwards. So from end it goes two backwards. Therefore it's going to be 40. And I'm not going to execute this and you know what's going on. So previous essentially creates a new iterator without changing the original and goes backwards and forward to what you want. Insun, tell me. You said no. Insun? Insun? Okay. Guys, when you log in, there is a test over there that makes you help check and see if you have an echo. If you don't do that echo, then your audio is not going to work. Please, please pay attention to these uh, details. When you're coming to class online, make sure you click on that one. You hear your own echo, and if it doesn't work, it means you didn't choose the proper microphone. So please do so, please. Okay. Uh, Anyways, and sound, please type. And if you have problem with your uh, audio, you fix it like this. I'm gonna put it over here. I'm gonna lose my audio, but look at it, see how I'm doing it. So you click over here, then you can select the one that works and change the audio. So it can select the proper microphone so you can actually talk. Anyways, okay. All right, so that's previous or prev, I'm gonna call it. The next thing is interswap. So what happens, it swaps the elements pointed by two iterators. So if you have two iterators pointing to in a container, you want to swap the value between the two. That's what the interswap will do. So essentially, if I have a vector and it is pointing to the beginning and iterator 2 is pointing to the third one, then if I say swap, it swaps the value between the two. So essentially 10 and 40 will exchange values. Uh, there you go. So if I actually go through them, you're going to see that the values between that the two iterators are pointing to will essentially change. You see? So to change the target of the two values, you can do that. So that's that one.
Professor,
Yes,
yeah. So I noticed in the previous examples you include the iterator library. However, here you didn't.
because I
So I'm
have the, oh
thinking,
yeah, I put algorithm over here. Algorithm includes that one already. Sorry.
so
So
it's necessary to
it's
include
necessary if you
the
are using it. This is because I have algorithm over here. It
yeah.
is doing that, but it is algorithm is including iterator. This should work if I do iterator over here. Okay. Anyway, so it's in here it's algorithm that I'm doing, but you can do iterator over here and it's gonna be the same. It's like when you are including IO stream, you don't need to include cstdio because it includes cstdio. It's something like that. Sorry about that, but thank you.
Oh, gotcha.
All right. So this one is interswap mcde interswap iterator swap. So it swaps the iterator. Now the other one, so the reason that I included algorithm over is it's algorithm over there, and the other one is iterator. Um, um, I'm gonna explain the algorithms, then we'll come back and I'll continue with the iterators. Then the your question will be answered too at the same time. That why it's iterator and over there is algorithm. We're gonna go through that one too. But anyways, so this is so far this is the iterators, and there is one thing you need to remember that these actions are extremely notorious, which means when you do advance, if you go more than advance, it's like C functions. It has not the behaviors that are not uh, uh, defined. So most STL iterator utility functions do not perform error checking and will not throw exceptions, return an error code, or warn you if something goes wrong. If you misuse them, for example, if you advance an iterator out of the bounds and pass iterators from different containers, like you put you have distance and you put an iterator in one uh, vector to an iterator in another vector, so the two are not they have nothing to do with each other. If you do stuff like this, your program may crash, your program may corrupt memory, your program may run into incorrect results, debugging becomes extremely difficult. So you have to be extremely careful. If you are actually doing things like this, you need to make sure that your iterators are valid and they stay within the boundaries of the container. Um, how all these things can be prevented? There are several different techniques that we'll talk about that later. This is, I don't think these are very much covered in the outline of the subject, but these are things that it's good for you to know. So I am not going to add this for now, the iterator swap, and then I'm gonna go through uh, um, the algorithms first. Then we're going to come back to iterator swap and another utility function called back inserter. We have to discuss this when we go through algorithms. Down to this point, do we have any problem with the utilities that work with iterators? Okay, Matin said yes, Insan said yes, and Ju said yes. You have problem. What problem? What can I clarify for you before I continue?
Oh, Professor, sorry, I thought you were asking a reopen with iterator.
Ju, you're too far from the microphone. Please come a little closer and then talk.
Uh, I thought you were asking that we are okay with the
Oh, I see, I
iterator.
see. Okay, all right. So,
Sorry.
no problem, no problem, no problem. How about Matin? You're good? You don't have audio, Matin? Is Matin here? Say with me, bro. Okay. Uh, yeah, Matin is here, but he's on mobile. So, all right. Okay. Um, anyways, let me know if there's any trouble. Now, what I'm going to do, I'm going to talk about STL algorithms. Okay. So, let me organize my pages. So, uh, let me just move my screens back and forth to a proper place so I can have things organized properly. Oh, I disabled the screen sharing. Yeah, the screen is back. Good. Okay, so let's continue. Um, so in C++, STL algorithms are pre-written functions that operate on containers using iterators, and their job is to simplify um, uh, all the operations that you need to do with containers, like sorting, searching, and converting data, modifying data, while and makes everything standard. So essentially, um, uh, these are in other words, I can say that the algorithms are a collection of functions mm, that that work on containers, like vectors, queues, lists, and all those things, and they are generic, which means all the algorithms are completely compatible with all containers, they are reusable, and they are extremely optimized for performance. The STL algorithms were introduced to C++ in 1990, so it's pretty old thing. Uh, and they are designed to separate the algorithm from data structures. So essentially, they want you to choose the proper container to hold your data, and then don't worry about the algorithms that's going to be used on those, because all containers work with these algorithms. They provide flexibility, and you can use the same algorithm across all different types of containers that you have. The purpose of them is to simplify all the common tasks, like searching, sorting, modifying, summarizing, and things like that. And they provide functional programming style that helps you write concise and readable code. They operate on iterators, all the algorithms. They not directly work on containers. And because of that, they separate themselves from data structure. Give me 2 seconds. My apologies. My daughter, the school is off too. My daughter is screaming downstairs, talking with one of her friends. I have to go close the door. My apologies. Give me a second. All right. So, yeah, I was saying that the algorithms, they operate on iterators. They don't work with containers directly, and because iterators are generalized on containers, therefore algorithms work on all containers. Uh, so they work with all they're generic. They work with all the container types, and they are optimized with runtime performance. And these are all the reasons that we have to use STL algorithms for anything we want to do in our class. Uh, they increase efficiency. They are faster than any manual implementation that you're going to do. They are reusable, so you are writing less code. Uh, and they are extremely readable. So essentially, by looking at an algorithm, you know exactly from the name, you know exactly what does it do. So the first example that I can give you is the find algorithm. The find algorithm's job is to find the first occurrence of something of an element in a range. So essentially, for example, in this vector, I want to know where 5 is inside this vector. So I can call the find algorithm, pass from where to where the search should be done. So from beginning of num to the end of num, look for 5 and show me where is the first one. And then, as you see, it's going to actually, if the iterator is not equal to the last one, then you know it's actually pointing to something, so it can actually show the value. So you can actually tell if it's fine. With the distance, you can actually show how far it is from the beginning. So you can say found at distance nums dot beginning and the iterator, something like that. And if it's not there, then it won't find. So it's gonna if it's and I can std. Do I have everything? There you go. So it's going to say found 5 at 2. So it's at position 2. That's 0, 1, 2. Okay. So that's found. Fine. It's one of the most useful things that you can use. I'm going to call it algo, and then I'm going to say over here find, so we know that it's the find algorithm. So the find algorithm essentially, let me just see if there's anything that I need to mention. No, this is all good. The other one is binary search. So how does the binary search work? If you want to search through a sequential array of things, so if I have over here one, if I want to search through something like this that sequentially uh, is sequentially ordered using binary search, what you do, like for example, if I want to find out where 5 is, first I'm going to go halfway through at here. I'm going to look, and I'm going to go here and I'm going to say, is 5 greater than this or less than this? If it's greater than this, I'm going to look in the second half. If not, I'm going to look in the first half. So I'm going to go to the first half. Then I'm going to say, is 5? Then I'm going to look at the middle and I'm going to say, is 5 is a match? Yes, it finds it. So this one was lucky because the second one was exactly in a half. It found it actually. So it searches very quickly. It goes half, 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 half until it finds it. Binary search is another one that is extremely useful to do quick searches inside uh, ordered elements. So if you have a set, it's a beautiful thing to go through. If it's a vector, you have to sort it. If it's a set, then you can easily use it on set because sets are always sorted. So as you see, it's gonna return a boolean and tell you what it is. So it assumes that the range is sorted. If it's not sorted, you're gonna be in trouble. Because it's binary search, it's supposed to be sorted, and uses binary search to check to see if 5 exists over here or not. Starts from the beginning, goes to the end, and searches for 5. Okay, as easy as that. Are we okay with the binary search? All right. Next one, sorting. One of the most important, like for example, if you want to do a binary search and you have a vector, what you need to do is to first sort it. So if you want to do the sorting, there's an algorithm for it. So you have a vector that is not sorted, you got to say start sort beginning to end, and voila, done. So it's going to sort everything. But remember, sorting needs to be able to compare the two. So these two, the arguments of this should have less than greater than uh, defined in it. So if you have two employees, you have to make sure that the two employees are comparable with each other using the less than and greater than operators. Otherwise, the sort is not going to work. Okay? So that's sort. And it has many different, I'm going to give you different examples for sort, but this is number one. Okay? So yeah, it rearranges the vector to sort it.
Professor,
Yes.
does it always work with positive integers, or you can also
Anything
solve
as
with
long as
negative?
so if I have two vector of employees over here, okay,
Okay.
as long as two employees are comparable, what does it mean? It means you overload the comparison operators, then it sorts it. You remember comparison operators, less than, greater than?
Yeah.
If you overload those, then everything's going to work. Let me see, I have a message on Teams. I want to make sure it's not somebody. No, I thought somebody's telling me that they cannot log in, so I just wanted to make sure. Okay, sorry. So that's that one, and this one is sort. So EFGH. All right. So that's sort. I'm gonna show you later on how to use sort for with um, specific functionality. So, but this is so if you are using sort like this, the type of the vector, the, the types of the vector, the type of the vector should support comparison. Okay, so it's important for you to otherwise it won't be able to do the sort. Next one, modifying algorithms. Algorithms that modify values inside a container. Transform is one of them. So in here I'm saying I have numbers like this inside here, and what I want to do, I want to double each element in the range. So what I will do, I will say transform from the beginning to the end, okay, of vectors, and then start from here. So this could be another vector. So I could have another vector and apply the values over there. But in here, essentially, it says this is where you start transformation. This is where you end transformation. This is where you start uh, putting the results of the transformation. So this could be another vector, which means the results would have been set into another one, not changing this one. So yeah, what was so yeah. So essentially in here it says this is the start of the range to transform, this is the end of the range to transform, and this is the start of the destination range that will be overwritten. Okay. Um, and this is a lambda that I'm putting over there. So I'm going to say pass the value, the iterator, into here, which is an integer, and return it multiplied by 2. Therefore, everything inside the vector will be transformed multiplied by 2. And if I run this program, you'll see that I have 2, 4, 6, 10 over there. So that's transformation. So if you want to transform any data, or you want to um, you want to save the transformation in another vector, you can have some other vector over here and insert those values into it. Any problem, any question with transform?
Could you please explain again the parameters that we are passing, please?
Okay, no problem. No problem. Oh, let me fix this. It's algo sort. And this is I. Transform. Okay, so let me explain. So num's beginning, that's start of the range to transform. Num's end, that's end of the range to transform. nums. So the third one, that's start of the destination range that can overwrite source. Okay, so what I'm saying is that, let me just copy this. What I'm saying is that give me a second. Can you hear me?
Yes.
For some reason I lost the screen again. Give me 2 seconds. Can you see the screen now? No, you can't. No. Give me a second.
Not yet.
What's going on here? Give me a second, please. Can you see the screen?
Yes.
Yes.
All right. Okay. So let's continue. So what I was saying is that in here I can say std vector vector. Let's say integers again. I'm going to call it result, and I'm going to say it's going to be 5 integers, and I'm going to put values of zeros in it. Okay. Now in here I could have had result begin. So doing this now will start from here down to here, apply this function to each element of this iterator down to this iterator, return the values, set all the values inside the vectors to the results of that one. Therefore, the first vector remains unchanged and the results of the transformation will be in result. Does that make sense? Does that make sense?
Yes. Yes,
All
sir.
right. So that's I. So that's transform. Next one, replace. So this replace over here searches for occurrences of 2 from begin to the end and replaces all of them with 9. So if you want to go through a container and change all the values from one thing to another, this is what it does. So that's replace. Um, and as simple as that. So it replaces everything from the beginning. Yeah, that's that. I don't know if there's anything else to explain over here. So very simple and straightforward. So JK. By the way, I'm not showing you all the algorithms that you have inside the list of the things that we have over
Professor,
here. Yes.
Can you run that?
Well, here. So all the twos are replaced with 9. Good?
Oh, okay.
And
Good.
again, you see integer over here. This could be car. This could be employees. Could be anything. Remember, these are templates. Integer are easy. That's why I'm putting it over there. Okay? Just keep that in mind.
Another question.
Yes.
Can instead of 9, for example, like the previous example you did, we can also put the functions there as well.
To what? To add?
Like you instead of replace. So instead of saying replace to 9, as you did exactly like before, can we just say like double whatever the twos are there, like
No,
in the
then you use
previous one?
transform. You don't do use replace.
Okay. Okay.
The job for this
Okay.
one is to replace. If you want to transform, you call transform. Got it?
Okay.
And that
Yes.
Okay.
the professor, can you replace like multiple integers at the same time?
We did just.
Like let's say if you wanna
We did.
if you wanna
It's
replace
multiple. Two of them means
if,
multiple.
okay, let's say if you wanna replace like number 5 two with a different number, can you do that on the same like function?
No, you do another one. So you do another replace and you put 5.
Oh, okay.
Okay? Again, this is just think about it like this. When you say replace all the twos with 9, it means it compares every single one with this 2. So for example, if you have an employee over here, and in your employee you have an operator equal equal that compares an employee to an integer, and that integer is the employee number, you can put the employees in the vector and the employee number in here. Because the comparison between the two for equality is implemented, then all employees with employee number 2345 will be replaced by this. Do you understand that? Hopefully we understand it. I don't know. Yeah, I see. Yeah, okay. All right. Okay, so that's that. Now, numeric algorithms. The algorithms that kind of works with counting and things like that. So, for example, accumulate. Okay, I want to find the sum of many things. So this is what I do. So take a look at that. So I have a vector 1, 2, 3, 4, 5. So it adds all the elements from beginning to end, starting with the initial value 0. So essentially you're saying add everything from beginning to the end, start from 0, and then it sums everything up and it tells you what the result of the sum is going to be, which is essentially 50. And if I had 10 over here, then it would have been 25. Okay? So that's accumulate. So that's that. Let me see if there's anything else over here to go through it. Just want to see if there's anything missing in here to follow. Algorithms. Just a second. I'm just looking at the Okay, so now let's talk about algorithms and iterators. Okay, we talked about find. So take a look at this. So now in here we have a vector as an input that we're going to give to find. So it uses an iterator to go through uh, the range between beginning and end, and looks for the for 30, and the find over here returns an iterator. We can simply uh, using that iterator, we can change the value to whatever we want. So again, iterators that are returned by algorithms, you can use the algorithm to act to the iterator to actually replace and modify the algorithms, the elements of the algorithm. So that's the that's find and iterators. We talked about transform, you know exactly how it works. Another one is copy. So what does copy algorithm do? It copies the elements the uh, from the range beginning to end plus 3, and adds every single thing that it has into the sublist. Now this is another utility for the iterator that I said I have to talk about algorithms first and then tell you what it is. So back inserter essentially adds to the back of uh, uh, adds to the back of the sublist using an iterator. So essentially what happens is that it says get all the values over here and back insert it into sublist. So every single thing that is added, every uh, uh, element of numbers will be from beginning to 3 will be inserted into sublist, which brings us to the back inserter that I was talking about, which is the utility that I was talking about. So this uh, back inserter is essentially um, um, it's a way to add to the end of uh, every single container. So you can push into at the end of any type of container that you have. That's that one. So back inserters in MLMN back inserter. I'll go copy and back inserter. And I think that's it. Let me just take a look and see if there's anything else that I need to talk about in here. These are the things that I found relevant about algorithms. Let me just 345. So algorithms, let me see what do we have. Looks good down to this point.
Yes.
All right. So, um, what's the time right now? It's 2:38. We have till 3:15. So now that we know the algorithms, let's like have like 5-10 minutes break, and then we come back. We're gonna talk about the wrapper templates to see how we can actually use them and in algorithms to make our job a little easier. Um, so let's have like well, it's 2:39. We'll be back around 2:50. Okay, 2:50. Any questions before we go?
Sorry, I have a question.
Go ahead.
Yeah. So just to clarify, those algorithm functions, they can not only return iterators but can also return true values, right?
Which one?
Those functions we've been going through.
Utility functions, you mean?
Yes.
No, that's the problem. They do not return anything. They don't throw exceptions. They're very
Okay.
naughty. There is no way for you, like for example, advance. If I use advance over here and go 10, it's just gonna crash. You need to know what the size of your vector is, and you need to use those things within the range of your vector. So you have to take care of those things yourself. Okay? They don't return true false at all. At all. That's the problem with them. You have to be very careful. Okay?
Okay.
All right. Uh, a few, so not to completely disappoint you, there are ways around it. Okay? So you can put wrappers around it and write functions yourself that uses those things safely. But we'll talk about it later. Okay? Um, if we have time during the semester. But when I cover it and we are done with this, then I'm going to bring those things and give some touches so you can write, so you can actually use these utilities in a safe way. Okay?
Okay, no problem.
All right. So 10 minutes. Please remind me to resume recording. Hello. Okay. Shall we continue? So far we understood that we have functions written in STL library that essentially apply certain type of functionalities to the elements of containers using iterators. That's all fine and dandy, but um, to do all these things, I need to be able to specify different types of actions being done to specific elements of a container using an algorithm too. It's not just that I want to accumulate, but I want the accumulation to be done in a specific way. So I want specific type of logic to be applied to uh, items of a container. To do that, what we need to do is to be able to create something like pointer to functions that we have, but in a type safe and object oriented way. So we have wrapper class templates. That wrapper class template's job is to essentially wrap other things into a class so we can pass it around. When they say wrapper, it literally as if you wrap a gift so you can pass it along. It's something like that. So for a function template, for example, function wrapper, for example, this is what I can give you an example for. Of course it does. Let me see what's going on here. There we go. Okay, so as I was saying, I have a lambda over here whose job is to receive an integer and print it. And I want to be able to pass this function along into an algorithm called for each. For each is essentially an efficient loop. It loops through elements of a vector and applies a function to it. Now I want this, so I could have had this function as lambda right in here with no problem. But if you want to be able to pass any type of function into a wrapper and pass the wrapper around, this is how you do it. So you would say, I want a function wrapper of type returning void, receiving an int. So it returns a void, receives an int, and its name is print. And then you set it to a function that does exactly that. So this is receive an int and doesn't return anything, so it's a void. So passing the print to this one would essentially means this for each can pass each element of integer to print and therefore print every and each of this element. This is called the function wrapper. Now this function wrapper could have could wrap like I could have something like and something like that. So I print a line. So I could have something like that is perfectly valid too, which means this becomes a wrapper for this function. So any type of function with that will work. It doesn't matter. It's a callable thing. It could be a functor, it could be a function, or anything like that. So function wrapper's job is to wrap another function into a value and get it. And the good thing about this is you can actually put this as an element of a function, as an argument of a function, and therefore you can pass functions to it. So essentially a function wrapper could simply be in an argument of of a of another function, and for each has exactly that as a function wrapper over here as its argument, so you can use it that way. So this is what function wrappers are, essentially to wrap a function and so you can pass it along. It's yeah. So I want to see if there's anything else. So it wraps and yeah. Question about this. Question about function wrapper. Do we understand how to create it? Okay. So remember, the type that you see over here, it's what it returns. The types that go inside the parentheses are the arguments it receives. Remember that that's extremely important. The next thing you need to know, so element M and O. The next thing you need to know is what is a reference wrapper. Now, say I have a vector. Let's say I have 3 integers, and these 3 integers has 3 different values. I want to keep these inside a vector, but a vector holds values. It cannot hold references. So what I can do, I can create a vector of type reference wrappers for integers. So I would say this vector's job is to hold references of objects. And then I'll put over here ABC. So the ABC that I have over here is not going to be copied into the vector, but its references will be. Therefore, when I sort from beginning to end, therefore all the values will be sorted based on the references that we have in here. It helps maintain the references of entities into the containers for the algorithms. And we're going to use it later on in other things too. I just wanted to show you the syntax for it. So the reference wrappers that receives, you can pass references of objects to containers who normally receive values, not references. And that helps you change the value of the objects that you have outside of a vector and organize it any way you want. So that's essentially a reference wrapper. Just trying to see. All right, make sure it runs. All right. Binding. So let's say I have a function called add. So let's say I have a function called add, but assume that I want to have another function that adds 5 to any value that is passed to it. If I want that to happen, either I have to write a function that calls the add, so I can write something to do something like this over here. I can say int add 5 and in here I would put int x, and in here I would say return add x and 5. So this add 5 is calling the previous function adding 5 to it. So add 5 adds 5 to any integer using the general function add that we have. Do we understand what I want to do over here? Okay, so now that I have done this, this is an extra function call, which is not good because it's going to waste lots of time going from here, printing, calling another function. Instead of doing this, I can bind this uh, to a function wrapper. How do I do that? So I can say over here auto add 5, and in here I would say bind, and I'm going to say bind the add function for argument number 1 and put 5 in it. This means I want to bind add 5 to function add and let the first one be, don't touch it. So this means the first argument will remain as is, but the second argument will be 5. So essentially this placeholder one means first argument, and 5 will replace the second one. Therefore, anytime I call add 5, it will have x as first argument, but second one will be replaced by 5. Therefore, I can do something like, say I put, let me just say using namespace std so I don't have to keep typing. So I create a vector. Let's call it nums 2 and 3. Then I create another vector, result, and I'm gonna, oh, this is a vector of type int, sorry. And result, and I'm gonna make the result to nums.size. Okay, so result has the same size of nums, and then I'm gonna say transform nums beginning nums end to res begin, and all I need to do over here is to say add 5. So what happens over here now when I go for int res cout r, when I do something like this, you will see that 5 will be added to each element of nums. Okay, so with a binder, with the bind function template, I can create function wrappers to already existing functions and replace their arguments to default values if they don't have default values of their own. And so with, yeah, that's it. So like this, you can call any function that you want and pass a specific value as its default argument. That is binding. Are we okay with binding? All right. All right. We have lots more to go through. Yeah. Okay, so I please go through the algorithms so when you come the next time to the class, I can go through the rest of it, and hopefully we can continue uh, uh, with our topics. Actually, if I do this, I think I'm going to be done for we're going to be done for the first half. I'm going to make sure that, let me just see. Oh, file streams are next. Algorithms are, let me check to see. I think if we go through this, we're going to be done. So, yeah. So anyway, so please go through this, go through the notes, and if there is anything that you have problem with, you come next day so we can actually uh, complete it. So we're going to be done with the topics we're going to cover for the first half of the semester. Any questions before we go? And please be on time next time. Any questions? All right. Have yourself a beautiful day, and hopefully I'll see you next day. And the questions for the midterm is going to come up by tomorrow night. So be ready for it. Have yourself a beautiful day. Bye.